right, good afternoon. How's everyone doing today? Good. All right, cool. Everyone had a good lunch? All right, cool. Hope everyone's not too drowsy today. Well, first, thank you for coming. I'm very happy to be speaking with everyone here today. My name is Joe Andraka. I'm an ISV technical evangelist here at Salesforce. So what we do is we work with the App Exchange and all of our ISV partners and help them adopt emerging technologies and understand how to work that into a managed package. So today's presentation really kind of came out of development with our partners and trying to understand with emerging technologies like IoT and Einstein Analytics, the need to try to bring those together. And this is a framework that we put together and have been working with multiple partners on trying to adopt. So how many ISVs do we have in the room today? Okay, great. SIs? Consultants? Just developers? Okay, cool. Well, I think there's plenty of information, and hopefully just get some juices flowing in your mind on how to think about the new technologies we got going on today, and how you can take advantage of them. So this wouldn't be Salesforce if we didn't have a forward-looking statement slide. So we will be talking about some forward-looking features. Please make sure you make all buying decisions based off of what's currently available. So first I'm going to give a little background. I kind of introed it. Then we're going to go over the challenge that is faced by trying to combine these two different types of technologies. I'll go over the solution architecture that came up. I really want to make sure we have time to go over a nice demo so you guys kind of understand and feel free to start working with it yourselves. I'll go over kind of like lessons learned and then some next steps, and I'll make sure we save at least like 5 minutes at the end for questions if everyone has it. Sound good? All right. So in talking with a lot of partners, what was starting to become apparent when they wanted to work with IoT was that there was going to be a huge amount of data that was going to start flowing through the system. And what they were concerned with was they were going to be looking at all this data and not have the proper tools to understand it. So I kind of made the analogy of, what if you were on a ship and it looks like it's smooth sailing ahead, but you're actually going over a minefield and you don't even know it? Well, that's great because we have modern technology that could help with this, radar. But how does that apply to Salesforce platform? That's how we're going to be using Einstein Discovery today to help you use that as your tool and radar to try to help find signals in your data of all this IoT data coming through so you can make sense of it and make it actionable and even preventative. And then you can start to think where those use cases go from there. So typical IoT use case is everyone's going to start hooking in their devices. They're going to start emitting in a whole bunch of information. But if you don't have the proper tools, kind of I mentioned, to really understand all that data, how many people have actually worked with IoT orchestrations, platform events? Okay. And how much reporting is there on platform events? Yeah, right, okay. So you got to start to figure out a way how to architect that in. It doesn't come default. Now, it's great for state-based information. We understand what the status code was, maybe what a couple of variables were on it, but we don't understand how that reports and works into the overall trend of that asset. So we really want to use the technology and AI that's provided to the platform to start to pick out which one of those events that are coming through might be putting us in harm's way. And what this actually starts to do is starts to lend us to a couple of use cases. The first, as I mentioned, was trending your device status. Okay, so how do we just start to see device trends over time and see how they're performing? See what standard uptime is, average temperatures, average cycles, as we'll go through in the demo today. The next is then how can we enhance our IoT process with that type of information? Now that we know trends, now how can we start to understand it? Maybe trigger some service processes based off of that, trigger some outbound. Instead of having to escalate cases and be retroactive, we start being proactive once we start seeing specific signals. And then once we start to, like I said, predict signals, once we know what that should be, we know when we start getting anomalies. So then that's going to be where we can start to go, hey, I think we got a problem here. Let's take a look at this rather than looking at these 10,000 events that just came through. So that's what's going to start giving us the smarts. And then, like I said too, is so now that we start to make some predictions on top of this, now we can start drive some intelligent processes on that. Let's create a case. Let's follow up with the with our customer and see what's going on, and maybe have them run some status checks or do some preventative upcycles and cycling of the device. And then this starts to lead to a very interesting question: is can we then start to predict inventory and work orders for our service? If we know when a device is potentially going to fail, well then and with great certainty, then we should know where we can start having assets and inventory in certain regions and locations, and we can start forecasting our labor as well. So there's a lot of rich data that can go into it. Today, where I'm going to take you guys into is up halfway, predicting device event failures, okay? But with that framework, you should be well equipped to take it the next 2 steps, depending on what your use case is, all right? So when I first started looking at this, there's a couple challenges that we had to face. The first is that Einstein and IoT, we have the data, we are trying to get that insight out of it, but there was a disconnect. And the first was IoT is platform driven, where there's only a 24-hour replay, but if I want to start to make a discovery story, I need to have data that I could pump into this thing to start creating those trends and creating those stories. So I was like, okay, we're going to have to figure out a way to turn these platform events into some sort of data source that we could push to Einstein. The next is IoT is event driven. Okay, so if you've worked with the orchestrations in the past, you're just kind of seeing what that status code, what those attributes are as they're coming through. You really don't understand. They're all sequenced based off of that individual event. But whereas Einstein's prediction is record-driven, right? It's a transaction on the database. We have to use a trigger, and now with the new summer release, we can start to use evocable apex in either like a flow or process builder. So little hurdle we have to get over there. Still have another one. Events are isolated and static, and what I mean by that is it's especially when you're using the orchestration, they had these states that you were working with as they're coming through. That's slightly changing now. It's going to be used through flows, and we'll talk about that on kind of next steps. But just to understand that you're just kind of getting a series coming through where we kind of want to understand the big picture of what's happening. But in Einstein, we really want to try to get that timeline trend, right? It's kind of like a snapshot versus the big picture, the story that's happening. And the last was IoT is, again, because it's state-based, it's a state-based workflow, okay? That means we can only take action every time something comes in. Whereas with the Einstein, we got Apex workflow. So there was a little bit difference in the way that we had to architect it. But that was okay. So I kind of put my thinking cap on and said, well, we kind of know in a big picture, we got an event coming in. Something's going to happen in the middle where we're going to get data coming back out. Then we're going to be able to call that prediction from Einstein. So then we can get our event back going back into IoT or our preventative maintenance process. Okay. So what we started to come up with was, I think I had one too many transitions in there. Sorry. Okay. So what I came up with is we needed to create first that object that we can start to aggregate so we can build our story off of it. Okay, so in this, you could use Process Builder very easily on any event, platform event, and then you just archive it. And then with the asset ID that's coming through, we archive it associated to the asset. So now we're going to start getting that historical data that's going to come through with every platform event. And then that's going to be our basis for training Einstein. Okay, so then we can start to create our Einstein analytics data set based off of that object, as well as our discovery story, which is going to allow us to make a prediction. So then next, we're like, okay, we could use the Apex trigger that's provided in documentation. We can now make a call out to Einstein Discovery based off of that new custom object that just got created, and we can make a prediction, and we can then send that using an event or any other type of process back in to our IoT event monitoring system. So really quickly, we got pretty much all declarative now with the summer release of the Discovery Writeback. You can make that Apex process builder right now. So this could be 100% declarative as well, which makes it even easier for anyone to kind of get your POC up and going and get it running. So, wow, I'm going really fast. Okay, but I got a lot of cool stuff to show you. So let's run through the demo. So if I switch my screen, there we go. Okay, so let's run through this, because I think this is really what you guys came to see here too. So we're on an asset in Service Cloud, and what I've got here is a couple things. First, we have Einstein Analytics populating based off of the historical information of the events that have come through. We have status codes 0 to 4, 0 meaning A-OK, 4 meaning critical failure, okay? And as you can start to see, we've got average cycles, and we got average temperature being aggregated by the two that's coming in. So we're sending in an asset, we're sending in the time, the cycles, and the temperature for that asset. And this is giving us a very nice visualization with us. As you can start to see right here, there seems to be a correlation with critical failures, temperature, and cycles, right? So as temperature and cycles start getting a little high, the device seems to start failing. And this is just demo data. It's not like anything, but you can start to see that and start to understand that with Einstein Analytics. Now what we got over here on the other side is we got Einstein Discovery. And so what Einstein Discovery is doing is it's making a prediction against the model that we made with every event that comes through, and is predicting what's the likeliness that this event is going to fail, or this asset's going to fail. And that's that 4, critical failure, okay? And I'll go through the way that we trained it, but I want to point out a couple cool things that we see here. What Einstein Discovery also tells us is what are the leading causes for the prediction. So now, does everyone kind of understand kind of how Einstein Discovery works? Everyone, show of hands, so. Okay, so it's what it's going to do is it's a statistical model that's going to get created, and it's going to show what are the statistical correlations in your data, and we'll walk through how we do it. But when we get those statistical correlations, you're never going to have really like a 0% or 100%. You know, it's always going to be some distribution in the middle. So 13 is a good number right now, because we wouldn't expect 0. But then once we start getting that statistical model, we're going to be able to start to understand what are the leading causes for why Einstein Discovery thinks it's a 13% likelihood of failure. And so it's telling us that the temperature is in this range, and other factors, those can kind of pop up sometimes because it groups based off of a lot of, I'll walk you through how we did it, but if you put in like a lot of data that has like multiple attributes, sometimes it could pop out as another. So sometimes it's good to kind of make like general buckets of your data so it finds a simpler signal. But then what we could also do down here is it also gives us a remedy. How do we make this better? Now that's going to come into effect a little bit later when we start sending through event data that's going to start having high cycles and temperature. It's going to say, hey, get the cycles and temperature down. But that's great information for, say, a field service technician who's going to be pulling up this ticket and starts to see, and maybe it's a more complex machine or device that's, hey, on average, it's going to fail if it hasn't been recycled, or the device hasn't been recycled in, say, the last 24 hours, or You could build in all those variables as you wish. So this is saying change the time. So maybe at certain times of the day it gets overloaded versus other times of the day. That's all great information that a technician could use and arm themselves with when they go out on field and really kind of drive that one call, one stop to fix their unit here. So we also get with IoT Insights, we'll get to be able to see, and this is just a standard component that you can pull into the display here, is what the last trouble code was. So it came through with a 0, so it's saying everything's A-OK. The probability of failure was 12.5, so it rounded it to the 13. And then it said what the cycles and the temperature was. So everything's looking okay. It's in normal operation. So what I'd like to show you is, let's jump to the device, okay? And let's start throwing through a couple, let's start ramping up the temperatures and cycle, and let's see what Einstein starts to do and starts to tell us here. So I'm going to take cycles up to 75, and let's take temperature up to 55. And let's, oh, I got to log in, sorry about that. Okay, let's confirm that those are right. Okay, our event was sent in, and let's refresh our asset page. Uh-oh. So as we kind of started to predict, now, one thing that was important there to note, and I'll show you how we did this, is we sent it through with a status code of 0, okay? So the device was saying, hey guys, I'm doing okay, but I'm kind of hurting back over here, right? And so what we did is when I trained the Einstein discovery model, I took out the status code. I said, hey, don't worry about the status code. I want to know just based on the variables of temperature and cycles, can you find signals in the data? And this right now is Einstein is coming back and saying, hey, I think we might have a problem, okay? And so that's the power right there of seeing what Einstein can do, because now based off of this, we can start creating a case. We could start ordering a new asset. We could dispatch a service technician out there, given that we start having this richness of data inside of our platform, and that we could start taking some actual insights on it. And then we could also see here is what were the reasons. So as I showed you before, now it's saying that the reasons why it caused this is because the cycles is between 70 and 90, because we increased it. And if we go down as how to improve that, it's saying the main thing right now is temperature's got to come down. So that's going to give that field technician the ability to go, okay, hey, I know how to diagnose this. Let's try to bring the temperature down, whatever we have to do there. So we could run through another one here. Let's take it up some more. Let's make it really hot. Let's see what it says. And again, we're going to run it through status code 0. So there's no effect on what Einstein is telling us. And let's refresh. Maybe one more time. It is a trigger that calls out, so sometimes it just takes a second. Not sure why it didn't go up, but it is noting that the temperature and cycles has gone up. I'll ran through this 10 times this morning, but every time in a demo, something has to go wrong, right? So my apologies. But I think you guys are starting to see how a user could use this, but let's really dive in behind the scenes now and start to kind of show you guys how can you build this yourself. And like I said, there's not much, but just some declarative features that we can walk through. I will show you the most complex one using an Apex trigger on how to make that call out. So if you really want to control order of execution, especially when you're using platform events, can be a little tricky. So sometimes you could use your Apex to control that if you're using other processes, which can be helpful. So what we have is an inbound asset event process. And if anyone's worked with platform events and process builder, what you have to do is one of the fields that is coming in from the platform event, you're going to link that to a record in Salesforce. And you do that through a matching here. And so we're going to say that from the inbound asset event, we're going to look up the object, and I want to look up the asset ID is going to equal the event asset ID. So now we have a hard match because we're getting this, the event's coming from an outside system. It's not inside Salesforce, so we got to make that relationship. So that's the first step. Once we do that, then we're able to create our asset event record, okay? And all I'm doing is putting in the asset ID, so it's related to the asset that we want. We're going to populate the cycles. We're going to give the time as of today, as when it just ran. We're going to populate the hour from the device. Now, these are a couple other things, and this is where I think the real juice of this solution comes into play. So on the asset, I am aggregating up all of the average, we're doing max cycles, min cycles, average cycles, max time, or max temp, min temp, average temp, but you can keep expanding on those variables that you are capturing on that event when that event comes in. So say your device works outside and weather highly affects your devices. So maybe you know based off zip code of where that device is that you ping weather.com to see what's the current weather when you got that asset or when you got that event coming through. So what really kind of drives your process is where you can go crazy here. But this is what's going to start to give you those additional signals that when we push it into Einstein Discovery, that it's going to be able to find that and really start to hone down and make a very more precise prediction for you. So if we're looking at, we want to make trends, we would do it like say, hey, what's the average temperature for the last 3 days, maybe the last week, the last 30 days, last 90 days. We can go as crazy as we want with it, but for the purposes of this demo, we just did some basic roll-up summaries just to show you the concept and the way that we would train a model based off of the historical data of the event at that point in time. It does get into a funny wrinkle because if you're migrating a lot of data in, you have to do it depending on your process. If you don't have these aggregations built up, you would have to recreate those aggregations at that point of time. So that can be kind of fun. Depending on the massive data load, you might have to do some cleanup and data cleanup to populate all that. But that's what's going to give us that trend that we can put into Einstein Discovery. So once we have that, we need to create a training field on the asset event that we brought in. So this is a simple formula field, and basically what I did is I said, hey, if it's status code 1, we're going to set that to if it's status code 4, we're going to set that to 1, because what we're trying to do right here is Einstein Discovery can make 2 types of predictions. You can make a percentage, which means that we're going to predict anywhere between 0 and 1, or we can predict any number. In this case, we want a likeliness, so we're going to convert values into percentages for the purposes of trying to predict the likeliness. So when I get a 1, obviously 0 else, if it is a status code 0, that would always be a 0. So that's the majority of the events that have come through. But if it's a status code 4, basically we're trying to predict what a 4 is without knowing the status code. That's what this training value is going to give us. So then once we have this, what we're going to be able to do is go into Einstein or into Analytics Studio. We'll be able to create a data set from that asset event, and there's native integrator, so you can bring it right in a couple clicks. And then once we're inside of there, I'll show you what that data set looks like. So we have an asset event. And to create the story, all we do is go create story. And I'll show you what this looks like before we walk through what a story at the end of the day is. But all we're trying to say is we want to minimize that training for failure value, okay? Because remember when we made the formula, we said if it's status code 4, that's going to be 100% likeliness of failure. If it's a status code 0, that's a 0. So we want to take that formula field, and Einstein's going to crunch the numbers to tell us what do we have to do and what does the data look like, trying to make that as close to 0 as possible. And then that's what it goes into the recommendations we get back in the Lightning component that tells us, hey, what are the leading causes? Because if I switch this right now, we're going to get actually the opposite recommendations, right? We saw some that were green. I'll show you right here. We saw these ones are green. See, that's telling us how to bring that number down to 0. And then the red ones are telling us what was causing it to go up towards 1. Okay, so that's how the statistics is working in the background. But if we flip this, that's going to kind of do the reverse. So it kind of depends on your use case. If it's like an opportunity, we want dollars figures to go up, we would say maximize amount. But in this case, we want to just minimize that probability. Sorry. Okay, cool. So we're back in analytics here. So once we do that, we say where we want it to save, and then we're going to go to data options. This is going to tell us what fields we want to include in the prediction. Okay, and an important thing about predictions is we don't want to have any leading fields. So the number one that we want to remove is the status code, because we want Einstein to train without knowing the status and try to understand that. And then that's how the model is going to start learning. And we want to bring in all these min, max cycles, those aggregate trends that I brought into the object, because that's going to help it start seeing some deeper signals based off of what's happening with that asset over time. So then we would go, and then from here, we just say create story. So you need 1,000 rows of data. If you have a lot of platform events, that shouldn't be a big deal, kind of bringing that over. I'm not going to create the story right now because I'm going to show you what one looks like. Depending on your data set, it could take anywhere from 5 to 20, maybe 30 minutes to train the model, so it's pretty quick. But then when we got our story, this is what it tells us. So now this is kind of looking at it from a different lens. So first, when we're looking at the asset record, we were more like the field technician, trying to understand, hey, what's going on with this asset? This is more like your business analyst view now, looking at your data and trying to understand how are these device events related to device errors. And so off the bat, temperature is explaining 34% of the variation in this scenario. So that's when we send in the really high temperature. It said, hey, get the temperature down, because that will dramatically reduce it the most. When cycles are in a certain threshold and temperatures in a certain threshold, there's a different correlation. And this is out of the box. I didn't have to do anything. Once the story is done, you get this information back instantaneously, explaining your data exactly how it is from the data set that you gave it. So great insight. And the difference between these recommendations and what you have on a record level that we see is this is looking at the data as a whole. So how does the temperature correlate to everything that I'm looking at? When I'm looking at these specific items, this is how the model that got generated by all the data relates specifically to this last event that came through. So that's the difference of what we're seeing and the different metrics that we're looking at. The next part, so this is great, we got a model. Then you're able to deploy this model by just clicking deploy, and that will make an Einstein discovery model that we could start to call out to. There's a couple last steps. There is a Labs app provided by the product team that you could install in any org. This will give you give you Apex classes as well as invocable classes you could use in Process Builder and Flows to create predictions on any object that you need. And once we install it, I'm just going to show you what the trigger looks like. First, you're going to make a custom setting. So this comes with the package. And all we have to define is what's the object, the prediction definition ID, so that's the model ID that we created. An actual record gets created there. And then we just say what fields we want it to save it to. So we create 3 fields. We create a number field and 2 text fields. And that's where all the data gets saved from discovery. Once we have that, we're going to use an Apex trigger that is going to make a call out. So here, the Apex is very simple. Just a couple lines of code. We give that custom setting variable here, and that was it. To kind of get this going. Now, the reason I do show the Apex is that in the cases where maybe you're bringing in a lot of data sources into Einstein Analytics, because Analytics has a lot of preset connectors, maybe you're going to bring in some BigQuery data, maybe you have some Redis data you want to bring in, maybe you have something from Azure, anywhere, there's a pre-built connectors, you can ingest that data, but if you do that, because the predictions have highly correlated fields. They need those fields populated for a prediction in certain, it really kind of depends on your data set. So when you test the predictions, you may have to make a small little aggregation class right here that goes and queries those different values so that you can pull it together and then send it to Einstein Discovery so it has all the required fields it needs to bring it back. But in the simplest case, if you're just using it on straight platform data, you wouldn't have to worry about Apex. You could just use it through Process Builder or flows. You'd be totally fine. But if you are using external data sources, just know that can become an issue that you'd have to work around. And that's it. And then this trigger gets invoked every time that asset event gets created and then populates that prediction for us. So no rocket science here. You don't really need to be a data scientist to really understand this. Really, if you want to get into the weeds, just general business skills of understanding the correlations in the stories is really all you need to know to get going here. So we got, wait a second. Sorry, I'm so used to Google Slides, and then when you do these events, they make you do PowerPoint because it's got pixel perfect presentation skills up on here, and I'm a little whacked out, so. But it's all good. See, look what I did. Yeah. I believe it's, right now, I want to say it's about 100 variables per story. Off the top of my head, I can confirm that for you. I definitely know if you go to help and just go to like Einstein Discovery, it'll show the limits. I know from a row perspective, it could take a 500 million rows of data right now, and they're looking to expand that to 1 billion by Dreamforce. So this is all on our future-looking statement slide, safe harbor. But that is the plan. They're really looking to scale it up so you can bring in all that data. And I'll definitely got to talk to that point in one more slide here too. So yeah, great question. Okay, cool. This is working again. So kind of recapping, what do we do here? So I know we kind of like went through the back end a little bit, but just like overarching architecture of what we did, because use cases may slightly vary. So what we did is we brought in a platform event, and we used Process Builder to archive that event, okay? When we archived that event, we took all the aggregation values from the asset at that same time. So that was all the other fields that we added to it to give it that, that point in time trend as to how those specific stats related to prior events, okay? Then that custom object was what allowed us to push it into Einstein Discovery so we can start to make a prediction model. We use, in this case, an Apex trigger, but as I've mentioned a couple times, if you're using just straight platform data, whether it be big object or S object, the process builder will be just fine. It's only if you're really going to get into, if you're going to have order of execution issues, maybe you might move it to a trigger just to make sure that you could separate process builder from firing events or any other validation that you have going on. And then we're able to send an event back out to our IoT process. So that can be another process builder, any way that you want to manage your IoT assets, that's going to be the way you do it. So a couple lessons learned. One, do not try to make IoT data by yourself. It is an extremely painful process. Try to really use production data. I did it. It took me and a colleague about 2 days of just banging our heads against keyboards to try to make 10,000 rows of data with some sort of just two variables have a correlated. It's not really that easy. So really try to work with your team, work with a customer if you're a partner, collaborate with them, sign whatever NDAs you need to do so that you get access to real production data, because that's going to help you the most to find real signals in the data that you could really build proper process around. The next is, as I kind of mentioned, because we have that trending that's going to happen every time that it comes in. If you're going to be migrating the data, think about how you're going to do that. So you may have to use a migration script to make sure that you fire in all the events into platform so that the processes can run, or maybe do the data enrichment off platform to create all those trends and then populate all the assets so you have all that historical information so it makes sense. Order of execution could be fun, and I kind of mentioned that a couple times, is you're gonna have platform events that are gonna get fired. I'll answer your question right in just 2 seconds. So you wanna kind of get around parallel processing. If you're using multiple events, make sure that you're not just triggering and kicking off like an explosion of events going off. You wanna make sure that you got reliance on platform processing for predictions. And now, as I noted, the predictions are invocable, so that's making it a lot easier to work with. You don't, your developers won't have to always be using Apex. They could just pop those into flows and process builder, making it a lot easier. And if you're going to be using super high volume, okay, I definitely recommend, instead of just dropping it into just an S object, drop it into a big object. Big objects are meant for archiving. It's a perfect use case for this, especially with Einstein Analytics. You'll be able to take it right in and create a discovery model just as easy, and it can handle the load. And then you would use like async SOQL, and async SOQL is perfect aggregation classes. So you just say, hey, I'll just do this and then save it to the asset, and it can be saving those on, say, a nightly basis, however works best for your process. A side note, I got two promo slides in here, is that there's been collaboration with our team and AT&T. They are going to be doing a integration streams workshop in 2 months. There is a gentleman right up here, Gail Wong. You could definitely contact or ask me for the information afterwards if you're interested in attending. They're going to be kind of providing some devices that can feed right into the Salesforce system. So pretty cool collaboration that's going on. If anyone else is interested, more than happy to intro you to our product team as well too, if you have any cool ideas with your team that has device data. And if platform events have been pretty fun, I'm going to be doing another cool presentation tomorrow morning, building a presence app inside of Salesforce. It's a Labs app that's available on the App Exchange. Anyone could install it in your org. So if you've been a little burdened by the confliction detection when two records are trying to be saved at the same time, that can help. But really, there's a lot of next steps, okay? First is Trailhead. We've got a lot of great trails for platform events as well as Einstein Discovery, so definitely get started there. You'll be able to get going really quickly. Next is then just create a POC. Work that into your use case. Test it out, play with the software. We give it to you guys for free for a reason. Play with it, have some fun, and see if it helps. And then share your story. Put it out there on a blog, talk to your customers, talk to partners, talk to others in the community, see how they're doing it, and see how you can get better adoption of your use case. So with that, I know we got a couple more minutes. I know we had a question over here. Yeah. It was, yeah. So every event that came through, it was making a prediction on it right then. So it was, yeah, it was. Yeah, so say if you have like a lot of data and maybe you might want to do something in Kafka on Heroku that might funnel something in and then pipe it into Salesforce, yeah, you can definitely do something like that too. So just on your use cases, but Salesforce does have some tools that you can pipe it in as platform events onto platform to help you, and then get the analytics that you're looking for too on top of it. Yeah, great question. Anyone else? Yeah. So asset creation, refreshing every hour. I think it's going to depend on your process, right? So if you want to create a batch job that's going to just consistently just keep running all the time, you can do something like that. It really is just what's the most statistically relevant. And with predictions, one thing that I found and what I've recommended to partners that I've worked with is good is good enough with these predictions, as long as you're kind of steering it in the right direction. You don't have to be super precise, but as long as you're like in a good direction, I think data quality is like the most important factor, like making sure that you got good data coming in here. The signals that you're using are strong signals in the data, and you're not just pushing kind of anything in there that may not find any signals. So like if you're running a lot of stories and they're really not correlated to it, I would drop those fields and maybe go try to look for other fields that might enhance it to help you a little bit better. Yeah, great question though. Anyone else? Yeah. So you can do that. You can definitely do that in the mapping. It was just easier to show people and explain how it's there, but you can do it either way. Yeah. No worries. Yeah. Anyone else? Well, cool. With that, that's time. Thank you very much. Enjoy the rest of your time at DX, and yeah, have a great rest of the day.